Advanced Math, Set 86, Arithmetic Progressions and Arithmetic Means. Okay, so there are lots of different ways to display numbers. This is one example of a number where the numbers are in a random pattern, and we say that these are non-sequentially ordered. These numbers, however, are sequentially ordered because they're in a list and there's one number following the other. Okay, when they're arranged sequentially, it's called a sequence. Okay, so a finite sequence has a finite number of members, like the examples we just had, and an infinite sequence has no end, so it's left open-ended with a ... Okay, so when we have a list of numbers, a lot of times we can denote them with variables with a subscript. So t sub 1, t sub 2, t sub 3, usually that's a term, and then a sub 1, a sub 2, a sub 3, and so on usually represent variables. Okay, now we'll talk about an arithmetic progression. You have a first term, and you add the same constant to form each succeeding term. So it's kind of like when you have a list like in a table, but written out. So this is an example. These are two examples where you have a list and you're adding the same number to each term. So the vocabulary common difference is the difference between the two terms. So an arithmetic sequence is the sequence that has a common difference between each term. So between 7 and 10, when we look up at the top, between 7 and 10 there's 3. Between 10 and 13 there's 3. Between 13 and 16 we're adding 3, adding 3, adding 3, adding 3 each time. If you look at part B, you're subtracting 4, subtracting 4, subtracting 4, and so on. Okay, looking back at these sequences again. Now we're going to talk about arithmetic means. And the arithmetic means are the terms between the end terms. So you have a first term and a last term, and the arithmetic means are the ones that are in between. So for problem A, those are the arithmetic means, and for problem B, those are the arithmetic means. So A has 6 terms and 4 means. B has 7 terms and 5 means. Okay, so we're going to examine these sequences in more detail. So if we're looking at the terms, the first term is 7. The second term, 10, is 7 plus 3. The third term is 7 plus 3 plus 3. And the fourth term is 7 plus 3 plus 3 plus 3, and so on. Okay, if we look at the next sequence of numbers, the first term is 7. The next term is 7 plus negative 4, then 7 plus negative 4 plus negative 4, 7 plus negative 4 plus negative 4 plus negative 4, and so on. Okay, so the green circled one represents the first term, second term, third term, fourth term, and so on. First term, second term, third term, fourth term. Okay. 7 in both cases is your a sub 1. It's the number that you're starting with. Okay, then we have a sub 1 plus d. So we have our initial term, and then we're adding the difference. Okay, for the third term, we have a sub 1 plus 2 times the difference. For the fourth term, a sub 1 plus 3 times the difference. And then if we go on to the nth term, it's a sub 1 plus n minus 1 times the difference. So we have the nth term. Okay, so the nth term, again, is a sub 1 plus n minus 1 times the difference, where a sub 1 is the first term, n is the number of the nth term, and d is the difference. So we'll do an example. write the first four terms of an arithmetic sequence whose first term is negative 14 and whose common difference is 10. So this is a pretty easy one. We know we're writing four terms. The first term is negative 14 and the difference is 10. So negative 14 is our first term. Negative 14 plus 10 is our second term. Negative 14 plus 2 times 10 is the third. Negative 14 plus 3 times 10 is the fourth. You really don't have to write that all out. Really, all you have to do is just do the math. Negative 14 plus 10 is negative 4, plus 10 is 6, plus 10 is 16, plus 10 is 26, and so on, but we only need the first four. Okay, now it gets a little bit more involved. Find the 25th term of an arithmetic sequence whose first term is 12 and whose common difference is negative 6. Now, we don't want to actually write out 25 terms, so this is where the equation comes in handy. So we'll go back to that equation, a sub 1 plus n minus 1 times d. A sub 1 is your 12, your difference is negative 6, and then we need to find the 25th term, so that's going to be 25 minus 1. If we just multiply that out, we get 12 plus 24 times negative 6, which is negative 132. Okay, another example. Insert 3 arithmetic means between 2 and negative 4. Okay, so the first thing I do is draw a diagram or draw an example. So we have our first number and our last number, and we need 3 means between them. So we'll use what we know to fill in our equation. We know a sub 1 is 2, and we know that our next term is going to be a sub 1 plus the difference. The next term is going to be a sub 1 plus 2 times the difference, a sub 1 plus 3 times the difference, and a sub 1 plus 4 times the difference. So that should be enough to help us figure this out. A sub 1 plus 4d equals 4, and we can see that because the fourth term is equal to that. Now we can look at the first term. We know the first term is 2. So since a sub 1 is 2, all we have to do now is answer this. 2 plus 4d equals negative 4. Subtract 2 from both sides. We get negative 6. Divide both sides by 4. We get negative 3 halves. So that's our difference. So all we have to do is go back up to the top and subtract 1.5 from each term. So 2 minus 1.5 is going to be 1/2, minus 1.5 will be negative 1, minus 1.5 is negative 2.5. And there's our solution. Okay, write the first 5 terms of an arithmetic sequence in which a sub 17 is negative 40 and a sub 28 is negative 73. So, again, we'll take what we know. We know a sub 1 plus 17 minus 1 times d is equal to negative 40. We know a sub 1 plus 28 minus 1 times d is equal to negative 73. We have 2 equations. Let's simplify that 17 minus 1 and 28 minus 1. And now we can use elimination to subtract the bottom from the top. So when we subtract, we change the signs of everything. A sub 1 minus a sub 1 drops out. 16d minus 27d is negative 11d, and negative 40 plus 73 is 33. So our difference is negative 3. Now that's not what we were looking for. We're looking for the first 5 terms, so we still have to do a little bit more. So going back to that original equation that we have, a sub 1 plus 16d equals negative 40, we'll plug d in. So a sub 1 plus 16 times negative 3 is negative 40. A sub 1 minus 48 equals negative 40, so a sub 1 equals 8. Now we have enough information to write the first 5 terms. First term is 8, the next term is 5. The next term, subtract 3 is 2, subtract 3 is negative 1, subtract 3 is negative 4, and that's all we needed. What?
Where's the box? Because I'm going to paint box.
Okay. 86.5. Find the 10th term of an arithmetic sequence in which the first term is 3x plus 2y and the 6th term is 8x plus 12y. So now we're getting a little bit more abstract. So a sub 1, we know is the first term is 3x plus 2y. And we know a sub 1 plus n minus 1 times d is how we figure out our sequence. So we can do 3x plus 2y plus, and now we have the 6th term. So n minus 1, 6 minus 1 is 5 times d, and that is going to equal 8x plus 12y. Now we just need to subtract 3x and subtract 2y, so we get 5d is equal to 5x plus 10y. Divide everything by 5, so difference equals x plus 2y. And now we'll just put it back into the equation so we can find the 10th term. So we're looking for the 10th term, so we'll subtract 1 so that n minus 1 becomes 9. We know our first term, and we know our difference. So we know our difference is x plus 2y. Our first term is 3x plus 2y. And now we just need to simplify. 3x plus 2y plus 9x plus 18y. Put them together, 12x plus 20y, and that is your 10th term.